ريكوردينج بدأ. طيب الملاحظة اللي حبيت أن أقولها أنه قلنا أنه if you have multiplexers هنا المultiplexer selectors.
دكتور ما نشوف السكرين حقك.
سامحني. اوكي
شكرا.
اوكي قلنا هذم المultiplexer selectors وهذم الفاريبلز تبع الفانكشنز يعني of functions. وهنا يعني how you can use how you can implement these functions using these selectors. فقلنا إذا كان if you have for example three selectors يعني 8 to 1 multiplexers. if you have three variables هنا تحتاج what do we need هنا what do we need يعني more than the multiplexer itself. هنا we need what do we need هنا واضح السؤال ولا لا؟ عندنا multiplexer فيه 3 selectors يعني فيه هنا 8 inputs 1 output, so هذا له 8 to 1 multiplexer. So to implement any function that has 3 input variables, what do we need هنا in addition to the multiplexer?
decoder.
لا هنا أي function مثلا ناخذ function f of a b c 3 variables قلنا equals sum of the mean terms 1 3 7 for example. هما 3 variables. اوكي يعني الماكسيموم هو 7 يعني what else do we need in addition to the multiplexer حتى we implement this function using the multiplexer. إذا كان هما 3 variables إذا كان نستخدم 3 variables as the selectors what else do we need?
Is it an 8 to 1 multiplexer? Is it an 8 to 1?
لا يعني أسهل بكثير من كده. طيب إذا كان ال A B C 0 the multiplexer will select I0 اللي هنا هذا. So what should we do هنا? What should we put in I0?
0.
We will put
and we will put in I1 1 and I3 1 and I7 1. That's it, sorry.
That's it. هنا 0 هنا 1 هنا 0 كلهم zeros وهنا 1. So we only need zeros and ones. That's it يعني to implement the function if we have a 3 selectors multiplexer. Okay. هذا الكيس يعني هذا كيس أول. كيس ثاني if we have 2 selectors only. يعني we have a 4 to 1 multiplexer and we have 3 variables. What else do we need to implement our
0 1 and 1 variable?
So هنا ما عندنا هذا كله. بس ما عندنا هذا كله. We have only 2 selectors. عندنا 4 to 1 multiplexer. So what else do we need هنا?
One more variable.
Yes.
We need
0 1 and variable.
0 1 and the third variable يعني let's say we choose these two يعني for the selection, so we need the C and the C bar. C and C bar. هذا هو يعني this is the maximum that you need يعني. Okay, now what if we have, for example, two selectors, يعني 4 to 1 multiplexer, but we have هنا 4 variables.
تصير C and D.
اه
C and D and C and D bar 1
Zeros
and
and
0
one.
and yeah صح؟
لا
دقيقة.
هنا let's say عندنا A B C D equals، طبعا هنا حيصبح عندنا يعني 16 min terms. يعني let's say عندنا 0 1 5 6 7 بعدين عندنا 10 11 and 13. Okay, so if we have يعني هنا
We will have 3 selectors صح؟ ولا 2؟
عندنا 2 selectors only. هذا 2 selectors. يعني let's imagine we are in this situation يعني. فهنا because we have
we need zeros and ones and C bar and C and D bar and D صح؟
not only
اه
لا مش only this. يعني هنا مثلا 0 0 0 0 0 1 3 4. Let's take just the first half يعني يكفي just to understand يعني الفكرة. zero zero one one 0 0 1 1 0 1 0 1 0 1. هنا we have F. So قلنا we have 0 1 بعدين 0.
1 دكتور صح؟
نعم
0
sorry.
نحط
Yes نعم 1 1 because min term 0 min term 1. 3 and 4 2 and 3 and 4 zeros. 5 and 6
1 1.
1 1 and 0 for 7. 1 for 7. Okay, so here because we have two selectors, we have to divide the table يعني 4 rows by 4 rows يعني. Okay, why? Because يعني A, B do not change every 4 rows. You can see that every 4 rows A, B, they are the same, they don't change. Okay, so يعني when we had the difference, the difference between number of selectors والvariables only one, we have to group the rows 2 by 2. إذا كان difference 2 هنا we have to group them يعني 4 by 4. فهنا يعني we need to express this يعني هذه الاكسبريشن اللي هنا يعني الفانكشن هنا will be selected في الاي 0. يعني this function هنا this function اللي هنا will be selected when a b is 0. Okay, so هنا in I0 we have to put this function here. And we have to extract from this the function f in these 4 rows is equal to what? Is equal to c bar d bar or c bar d, which is c bar. f is equal to c bar هنا. اوكي واضحه ليش ولا لا؟
دكتور معليش بس ممكن تعيد ليش طلعت؟
Why is it
نعم.
C bar? Why is it C bar?
لانه it is المين ترم الاول c bar d bar, it is c bar d bar or c bar d. This is equal to c bar d bar plus d. فهذا 1 فتبقى عندنا c bar. Okay, so هنا we need. نعم.
Doctor, didn't we group it for يعني group to 2 groups with each group has 4 rows صح؟
4 groups. هنا لسه في 4 يعني 2 other groups تحت. Each group will be will use one of these inputs. Okay, so هنا we will put c bar هنا. For the other one هنا we can see that this is f هنا is equal to C bar and D bar يعني C or D. So هنا we have to put C or D. واضحة
But
الفكرة
doctor,
ولا؟
we are leaving 2 rows. We are just checking for 2.
What do you mean?
Yani we are just checking for 2 rows of the 4. We grouped by 4, but we are just checking for 2.
بلس 2 صح.
يا دكتور ال1 وال0 وال11 ما اخذناهم ليش؟
ما فهمت فين 1 0 1 1 هنا 0 1 1 1.
We're checking
يعني
the F for the first 2 rows of each group. We're not checking all 4 rows.
لا the all 4 rows هذه الاكسبريشن of all the 4 rows. F هنا
بس
is
كذا انت
equal
اخذت
C.
ثنتين يا دكتور.
لا هنا أنا أخذت لأنه هنا 0 فأخذت F بار تساوي C بار D بار. F بار تساوي
اخذت عند عند الونز
عند
بس.
بار. فلما تعملها بار مرة ثانية تعطيك C or D.
Okay. Yes. Understood.
ويعني هذه يعني اوتوماتيك تشوفها هنا متى الاف تساوي 1 اذا كان عندي اما دي او سي او both of them which is هذه الاور بالضبط يعني.
صح.
So هنا يعني if we continue هنا التيبل we will have هنا كل ال combinations between zeros ones and any mean term using C D C bar D bar يعني mean term يعني you may have ands ors and nots. Okay you have to think about it زي البولينوميال. عرفت البولينوميال؟ بولينوميال x أس 4 ويساوي حاجة أس 2 مضروبة بولينوميال أس 2 مضروب في another polynomial أس 2. أوكي فالسم of الإكسبوننت هنا لازم يكون دائما 4. فهنا نفس الشيء هنا إذا كان هذا 2 وهذا 4 فهذا لازم يكون 2 خلينا نقول الدرجة تبع البولينوميال يعني. فهنا ما يقدرش يكون only 1. هذا الدرجة تبعه 1 هذا الدرجة تبعه 0. الدرجة تبعه 0 لأنه ما يستخدم أي variable. هنا يستخدم فقط variable واحدة. هنا يستخدم combination of variables يعني بيستخدم ands و ors و nots يعني حاجة زي كده يعني تقريبية. ف يعني this is how you have to think. فهنا مثلا لو عندنا if we have for example a selector let's say a multiplexer of 3 selectors and we have let's say 4 variables. هنا we will need what in addition to the multiplexer?
0 and 1 and
one
D
variable.
bar.
0 1 and the last variable مثلا دي ودي بار مثلا.
Yes.
اوكي يعني فدائما لازم يعني الدرجه بينهم الاثنين sum of the let's say ال degree of the polynomial حيكون دائما هو نفسه يعني حاجه تقريبيه زي كده يعني. اوكي هذه الملاحظه اللي حبيت يعني احكي عليها الصباح بدانا فيها في المحاضره وما خلصناها. طيب عندكم اذا كان مش واضحه ممكن نوضحها اكثر بس اذا كان واضحه ممكن نشوفوا اذا كان عندكم اسئله اخرى.
دكتور لو ابغى ارسم لوجيك سيركت
اذا تبغى ترسم ماذا؟
السيركت تبع اخر اكزامبل 2 selectors and 4 variables.
هنا؟
ايه
اي هذا هو عملناه هنا لسه ما خلصنا لانه ما عملنا كل التروث تيبل بس we have just to continue يعني.
I don't need to design the circuit to draw.
هذا هو السيركت.
اوكي
هذا هو
I
السويتش
think he
يعني.
means the logic diagram.
لا yes I think he means the logic diagram.
نعم, this is exactly the logic diagram. هذا هو, this is the logic diagram. And you have to use the multiplexer as it is يعني don't think of how it is built inside يعني.
Okay.
It's an available component, you just use it يعني it's part of the diagram يعني Okay.
Doctor, I have a question.
نعم تفضل.
What is a single inverter?
نعم.
What is
فين
a single inverter in chapter 3 slide number 55?
نعم هنا because هنا you have just one variable that is inverted. تحكي على هذه أنت.
I'm talking about there's an example on chapter 3 in the slide number 55. It says the example is implement F and it gives me the minterms with an 8 to 1 line multiplexer and a single inverter.
نعم هذا هو الانفرتر, هو حيستخدمه عشان يطلع السي بار هذه.
اوكي.
يعني استخدم 0 1 والفاريبل نفسها, واحيانا تحتاج انك تستخدم انفرتر يعني, فماكسيموم حتحتاج انفرتر واحد يعني.
اوكي.
في الكيس هذا تحتاج ماكسيموم 2 انفرترز. عندكم اسئله اخرى؟
ايه دكتور عندي سؤال ما فهمته.
تفضل.
دكتور اللي هو using don't cares in the K map, how should I take it?
Using don't cares in the K map. دقيقة أشوف كيف ممكن نضيف صفحة ثانية. ما أدري, أو ممكن هنا edit. Okay, apparently I can't. طيب مش مشكلة. طيب السؤال هو دقيقة. Not this chapter. هنا ولا في chapter 2؟
Yes chapter 3.
chapter 3 في أي سلايد عندنا example؟ في الانكودر with priority عندنا at least one example. صح؟ الانكودر عندنا example that is using encoder with priority. هنا في التيبل هذه عندنا هنا don't cares. هذا الاكزامبل اللي تحكي عليه ولا لا؟
لا ثواني بس دكتور الحين طلع, بس ثواني.
Maybe doctor it's slide number 17.
Slide number 18 doctor.
18.
Okay, design of a BCD to X3 code inverter. اوكي انا نسيت الاكزامبل هذا, بس why do we have don't cares here?
He told you in the question. Don't cares with CD 1010.
Yes, because the table هنا is not complete يعني. هنا we have codes from 0 to 9 and then from 10 to 15 يعني هذم كلهم don't cares. فهنا أيضا سنضع don't cares. فهنا always from 10 هنا 10 11 12 13 14 15 هذم كلهم don't cares دائما, لأنه الكود هذا مش موجود في البي سي دي أصلا, فبنحطهم كلهم اكس يعني. انت الشيء اللي ما هو فاهمه أنت أنه why they are don't cares or يعني how we deal with them when we
Yeah, how
group the
yes doctor.
Hmm?
How we can deal with them when we group.
You have to deal with them as jokers يعني like here for example if they allow you to have a bigger group you take them but you don't have to cover them all يعني like here هذا you don't need them they are not useful you leave them يعني like هنا you are taking this one and these two because they allow you to have a bigger group if you don't take them هتعمل جروب كده وهتعمل جروب كده خلينا ناخد هنا قلم أحسن يعني هنا if you don't take these you will take this group and then you will take this group and then you will be left with this one you will take it like this with this one here
And it will be correct also.
it will be correct but it will not be optimum يعني it's not the best solution يعني the circuit will be working correctly you will have a different circuit the circuit definitely will have a different function لكن because يعني it will be behaving differently in these situations لكن because these situations they never occur we will not see the difference واضح ولا لا يعني انت
واضح دكتور.
the circuit is is not a decoder is what is a converter sorry so the circuit is a converter يعني whenever we have an input here it will be converted the right way يعني هنا بالطريقة الصحيحة بس لأنه we never have these codes here we will never see that your circuit is different than the one that they found here واضح ولا لا؟
واضحة دكتور يعطيك العافية.
but your circuit will cost more لأنه it's not optimized لأنك
Yes.
أخذت smaller groups يعني هنا في الجروب هذا مثلا you will have 3 variables but هو عنده only one group وفيه كل الones يعني كل المين terms which is better.
دكتور عندي سؤال بس كيف أعرف إن عندي don't cares
اوكي
في السؤال يعني كيف؟
نعم حيكون عندك don't cares إذا كان الفانكشن فيه some codes that are not allowed مثلا ولا they never occur ولا if they occur we don't care about them. اوكي زي هنا في البي سي دي it's only an encoding from 0 to 9 بس we don't care about يعني the other codes are forbidden يعني they don't occur. اوكي يعني
so they are don't cares. okay.
اي هنا في specification هنا بيقول لك البي سي دي code is an encoding from 0 to 9 of any يعني any number is encoded يعني if you have for example 93 هذا البي سي دي representation تبعه هي تنعمل بهذه الطريقة 9 is encoded like this و 3 is encoded like this. Okay so we never encode يعني 10 directly يعني 10 is encoded each digit is encoded by يعني alone يعني that's why we never have 10 ولا 11 ولا 10 is only 1 and 0. Okay so
Yeah,
10 will be encoded like this يعني
Yep,
using the table that you have here. So يعني حسب specification you will see that you have don't cares sometimes يعني of course. Okay.
Doctor, can you explain the flip-flops again?
Okay. Flip-flops. This is chapter 4 هنا Okay, so flip-flops are used. انت تقصد flip-flops ولا latches؟
اللاتش اللي فيها
يعني-
نور جيت.
اوكي، لانه الفليب فلوب شفناه في اكسرسايز بس يعني. طيب this is the SR latch. فهنا the idea is that يعني before drawing this diagram we want to build the circuit that does this, that supports this specification here. Okay, and then we will be able to draw this يعني let's imagine that we don't have this diagram here. So the set reset latch is the most basic unit of of sequential digital circuits. قلنا sequential circuits يعني circuits where we have memory. It has two inputs. So the requirements are the following: the two outputs must be always complementary. Q and Q bar must always be complementary. Then the S input has to set Q to 1, and R has to set or to reset Q to 0. That's the specification. That's what we want to have. That's the component we want to build. Okay. So this is the circuit that is built, and we will try to see how this circuit complies to the specification and when it doesn't. So here we said, let's say we have S equals 0 and R equals 1. So first of all, we need to recall the truth table of the NOR gate. A NOR B is only 1 when both of them are zeros. Okay, we need these two inputs to be zeros so that we have 1 here at the output. So let's imagine that in the beginning we have 0 هنا في Q and في Q bar, and then we set R to 1. So S is 0 and R is set to 1. So here R is set to 1. So this will be 0 because 0 1 gives 0 here. So 0 0 we will have 0 0 here. So we will have 1 for the Q bar. Is it clear or not?
Yes.
If we set here 1, so you have to select the pen. If we set here 1, here 0, 1 will give us here 0. So 0 and 0 will give us here 1. And then the 1 here, when it comes back, when it loops back, it will not change the 0. It will not, we will not have a continuous change in the state of the system. And the system will be stable like this, will stay like this, will not change anymore. Okay, so here, for example, then if we set S to 0, if we set S to 0 and R to 0, here, let's set R to 0. So if we set R to 0, we have here 1. So this is 0, 0, 0 here will give 1, and the circuit will not change because we have already 1 here. So this 0 will not change. We had 0 here because we had 1 here and 1 here, but only 1 gives 0. So even if R goes back to 0, the information is saved. The state of the system doesn't change. If R becomes 1 and then goes back to 0, it's not important that it came back to 0. The important thing is that it went to 1, so we saved that information. So this is here the state is memorized. Okay. So even though
Doctor,
no.
Sorry for interrupting. Is it because it only saves the highest state? So if it becomes 1, it just saves 1. But if it starts with with 0, and then we high it up to 1, will it stay 1 or will it stay 0?
هنا it depends which input you're talking about يعني. It depends. If you put 1 here, we have seen that depending on the state of the system, of course. And if the system is like this in the beginning and you set R to 1, the system will become like this. And we will have Q bar set to 1 and Q will stay 0. And then if R goes back to 0, the system will not change. Will not change because of the values that we have. Yani just because of the values that we have, we just need to try to execute these values. So هنا عندنا 0, هنا عندنا 1. So هنا we'll get 0. Okay, this 0 and with this 0 we'll give 1 because we have an OR gate. So the system doesn't change. Yani the state of the system doesn't change. That's it, yeah.
Okay, I get it.
Okay.
Yeah.
Now if we set S to 1 and R to 0. So here, for example, let's say the system, we have zeros everywhere, and then we set S to 1. We will have exactly the same thing because the system is symmetric. We have to think sometimes with symmetry. It's good. It allows us to think quickly. The system is symmetric. The same thing that we have just seen now will happen, but in the other side. Here we set 1, we got 1 here. So now if we set 1 here, we will get 1 here. Okay, and when S goes back to 0, this will stay there. Okay, is it clear, or we have to do the manual
it's clear.
execution?
What if S set and reset are both 1? What will happen then?
That's explained in the next slide.
Oh, okay.
But Yani, just for now, we want to just see that when we have S is 1, R is 0, or S is 0, R is 1, the system behaves as we want. Now,
Okay.
the problem is when we come to these cases, to these situations. Let's say, and for some reason, someone sets these to both of these to 1. So here, because we have 1 here we will have 0. Okay, is it clear why we have 0?
Yes, because it's not 1.
Because we need
It's
that both
odd.
of them be 0 so that we get 1. Because there is at least 1, we have 0 here. Same thing for
And the other one will be 0.
Will be 0 also. So this is a situation that is against our specification, doesn't satisfy our specification. Here Q is equal to Q bar. This is what we call a forbidden state. Forbidden by us. We do not want that this state happens. Okay? So we will use the R latch without ever putting 1 and 1 here. Okay? If we do, the system will respond naturally. The system will give us 0 here and 0 here. Okay, but it will not have any meaning for our use of the system, of this latch. Because the set we want, sorry, we want the set here. When we set R to S to 1, we want Q to become 1. And when we set 1 to R, we want Q to become 0. That's what we want. That's why they call it set and reset. Set sets the memory to 1. Reset empties the memory and sets the memory to 0. So putting 1 here doesn't have any meaning, and the result also here is against our specification, doesn't satisfy our specification. So we will forbid this situation. Okay. Do you want to try the last situation, or is it clear?
It's clear, but is the questions about the tick related to the SR latch?
what tick?
where we have a clock cycle like the one we did today.
أي. Yes, يعني we may have you may have a question about يعني some timing diagram.
But how can I analyze it to know where when it comes to 1 and when it comes to 0?
هنا, because we do not have an enabler هنا, if you put 1 هنا, for example, يعني if you have something like this, let's say you have something like this is R, and this is S. So let's say we have, of course, they should not be 1 at the same time. Huh? So the timing diagram should look something like this. They never 1 at the same time. And here I should not do this. If I do this, here this is forbidden. Okay. So here we will have Q here. So here they are both 0. So in the beginning it's 0. If it's reset, it's 0. Now it is set, so it will become 1. When S goes back to 0, what happens?
It stays at 1.
It stays 1 because it saves the state until it is reset. It is set to 1 again, doesn't change, until we have the reset. When we have the reset, it goes back to 0. يعني هنا, if we do not have a clock or an enabler, we imagine that the system responds directly right away. As soon as R becomes 1, Q becomes 0. We imagine that. Of course, it's not real, but we cannot know how much time this will, how much time the system will need to react. Okay, so now it will go back 0 until we have another set here. Here it will go back to 1. And what happens here?
It stays at 1.
It stays at 1 because there is no reset. Here it will go back to 0 because we have reset. And here, what happens here? Here we can just put a question mark. We don't know. This is undefined. When they are both ones, it will stay 0. Sorry, huh? This is not the situation when we have undefined situations. Here it will stay 0, but this is forbidden. Forbidden. The undeterministic state is when they are both zeros. S is set to 0 and R is set to 0 from the beginning, from the beginning, which is here. Like here, for example, this is undeterministic. Okay. Do you have other questions?
Doctor, is there a question in the tutorials that is about this specific subject?
I feel
ticks.
I feel last one أعتقد. Let me see. Tutorial 9, I think.
Yes, Doctor, tutorial 9.
Tutorial 9, you have these questions here.
Can you solve it?
Okay. Okay, so
Doctor?
Now.
A Q bar is always opposite to Q?
That's what we want now. That's what we want.
Okay.
But we have seen that in this situation, if S is set to 1 and R is set to 1, here we will have Q and Q bar both set to 0. Both will become 0. Okay? That's why it's forbidden. واضح ولا لا؟
Yes.
Okay. So here in this tutorial, we had this SR latch, and then we said we want to have something like an enable that will be used as the clock. So we added an enable to this SR latch, okay? And then the question was complete the following timing diagram of an SR latch with enable. The enable, you have a clock used as an enable for the SR latch. So the SR latch that we got, I cannot draw on this. I don't know if I can copy something. A diagram.
You can draw on it. Tap on draw up.
I can.
Yes.
Okay, let me go back here.
Yes,
you
have
I
draw.
can draw.
Yeah.
Okay. طيب, let me. Okay, well. Okay, so here the solution that we had is the following. We had an enabler. Why it doesn't stay there? Yeah. Doesn't stay there. ما أدري ليش. Okay, no problem. يعني, it's easier to draw the diagram here. So we have an R. Then here we have NOR. And then we have the S here. So this is Q and this is Q bar. So we said that we can simply add here. Do you remember how we solved this?
Yes, we put an enabler, so it becomes a D latch.
No. That's the second step. Here we had this solution here.
We ended with R and S.
Yes. We had this end here, and then we had this end here. So this is the SR latch with enable. Okay. And now, why it's important to see this, because, and just to make you remember that when we have an enable here, when it is set to 0, nothing can arrive to the circuit anymore. It's like if we cut these connections, so the system will not change anymore. It will save its state as long as we do not have any signal coming from here, from the enabler. So if we connect the enabler to a clock, for each tick of the clock, the system will be able to react again to S and R. So that's what we have here. I don't know if I can copy. Unfortunately, I can't. Okay, so let me do this.
Is the clock the enabler?
نعم.
Is the clock the enabler? Is it the same thing?
It's not the same thing. The enabler is the input of the system. هنا the system هنا will be something like this. When you buy it, you buy a component, and you will see here you have an R. Here you have another pin, and you have an S in front of written in front of the pin. Here you will have another pin with an E written in front of the pin, and you have a Q, and you have a Q bar. This is when you buy it, you will find these things written here. Okay, but here, if you connect it to a clock, it will behave as a clock. Depends what you do with it. Okay.
Oh, I see. Okay. So here we connected it to a clock, صح?
هنا نعم. هنا we
Okay.
connected it to a clock. نعم.
Okay. Thank you.
طيب هنا let's say we have this clock. Not very يعني nice drawing. So this is the clock connected to the enabler. This is R. Of course, here it's 0. It's 1. Here it's 0. This is S. So S is 1 in the beginning until just before here. And then it will be 0 until here. Here it becomes 1. Until here. Okay, this is S. Now let's try to think about Q. So Q is 0 in the beginning. Okay, so what happens when the clock ticks here? Before the tick of the clock here, the system is like sleeping, and it doesn't receive anything. Of course, when the clock becomes 1 here, the system can react to the inputs. So it has an end. So يعني the 1 from the clock doesn't have an effect by itself. It needs either R or S, so that we have a 1 outgoing here or here. Okay. Is it clear or not?
Yes.
Okay. So when the clock becomes 1 here, S is 1, so the system will react. So here we will have just when the clock becomes 1, the system will react, and we will have 1 here. Q will become 1, and Q bar, it was 1 in the beginning. It will become
exactly so.
Right. It's always the opposite. Of course, if we have S and R يعني behaving as we want, يعني. If we put S and R to 1 at the same time, we will have Q 0 and Q bar 0, of course. Okay. يعني we have to take to يعني we have to pay attention to this. يعني S and R should not be 1 at the same time. Here, for example, they are 1 at the same time, but يعني because there is no tick of the clock, it's not a problem. Yeah. Okay. Okay. So now the system, the Q will stay 1 until this point. When the clock becomes 0, what happens here?
It stays at 1.
It stays at 1. يعني
Why, doctor?
of course. نعم.
Why does it stay at 1?
يعني أول شيء, before the clock becomes 0, it stays 1. Why does it stay 1? Because S is still 1 and R is still 0. Okay, so if they change, it may respond. Yeah, it may be fast enough to respond before the clock becomes 0 again. So here now, if the clock becomes 0, now we have 0, 0 as inputs here, and we said that when you have 0, 0, the system, the SR latch memorizes the state of the system. So it will stay 1, okay, until the next tick of the clock. Now, when we have a tick of the clock here, now the system will be able to read the inputs because we have the enable, and it will see that R has become 1, يعني the Q will go back to 0. Is it clear?
Yes.
Okay. Now when the clock becomes 0, يعني until all this time, these signals do not change. يعني so the state of the system also does not change. Now when the clock becomes 0, now these inputs are cut, يعني. So the system doesn't change anymore. So it will stay 0 until the next tick of the clock. Whatever happens here doesn't have any effect on the system because the enable is disabled.
Mm.
So now when we have this tick of the clock, what happens? The system will see that R became 0 and S also is 0. And we have seen that this means that the system saves its state, doesn't have any modification yet. So it will stay like this until. So here we can see that the clock deactivated just before S becomes 1. If S became 1 before, the system would have reacted, but now it will not react because the clock is disabled. So here it will not see this modification here until the next tick of the clock.
It will become 1.
Here it will become 1 because we have 1 here, and it will stay 1 as long as we have the clock and we have S here. So it will stay 1 at least until here. Here the clock is disabled, so it will stay 1 until the next tick of the clock, which is here. So here
it's 1 1.
1 1. Here عندنا 1 1, so it will become 0. This is forbidden. I don't think that here we have 1 1. Oh yeah, we have 1 1. Okay, so this is forbidden. This is forbidden, but يعني that's why يعني in the next example, in exercise 3, we want to make sure that this never happens. Okay, so here Q will become 0, but also Q bar will be 0. In a Q bar was like this. So here it will become 0, but Q bar also will stay 0. We'll have both of them stay 0. Okay? Which is not what we want. Okay, so then for the next exercise in the tutorial, what should we happen so that we never get this here? In a Q is equal to Q bar. Why? Because S and R are both 1.
What about if they are both 0?
Now,
What about if they are both 0?
S and R?
Yes.
If they are both 0, it's not a problem because the system saves its old state.
Okay.
Okay.
So
It's like if we disable the enabler, yeah.
Okay.
نفس الeffect. Do you have any other questions?
Yes, doctor. The example that we took today about chapter 4, the remainder.
Okay. Okay, so what's about it? يعني أنت عندك مشكلة في this example. It was this example.
It was unclear.
Huh?
It was clear, but not very much.
Do you want to do it again, يعني ولا?
If that's okay.
Huh?
If that's okay.
Hey, that's okay. No problem.
Okay.
Okay, so we have a very simple 4 bits processor with a minimal instruction set as follows. So this is the instruction set we have here. It's described here in more detail. So the operations that we have are add A to B. So A to B are the registers that are used by the instructions. So add A to B is an instruction that will add the value stored in register A to the value stored in register B, and will save the result in register RS. And also, if there is a carry, it will be stored in register RC. Then we have subtract. This is another operation. It will do the subtraction. It will store the result in RS, and if there is a borrow, it will save it to RC. Then we also have the possibility to read and write from the memory. So load at an address X from the memory will load the value of, that is stored in address X into register A. And save will do the opposite. We can save any register directly to memory using save, the name of the register and then the address where we want to write the data. And then we have this, the programming language has, which is the assembly here, has some control structures. So we can write a program like this: begin program, then we have our instructions, and then end program. We can stop a program at any time using stop program. We can also use this repetition control structure. Repeat until condition. Here we can execute these instructions, and then end repeat. Anything between the repeat and the end repeat will be repeated until this condition becomes false. So here repeats all instructions until the condition is false. Here Ri can be replaced with any data registry A or B. We can use any registry. Then or register. If Ri equals 0, we have this also conditional control structure. If Ri equals 0, we can execute these instructions. So the question was, I have prepared another one, but let's do this one. So the question was, we have 3 variables in memory, X, Y, and Z, 3 integer variables in memory. Write a simple program to find the remainder of dividing X by Y. So just as a reminder, the remainder is what is left if you subtract Y from X until Y becomes bigger than X. The result should be stored in X. Okay, so let's go back to the to the diagram. Can you see clearly here ولا لا?
Yes.
Yes.
Okay. Okay, so the idea is that as I said, that to compute the remainder using only plus and minus, you just need to take, let's say, for example, if I have to select this. So if, for example, if X equals 16 in memory and Y is equal to 3, so to compute the remainder of X mod Y, what should we do? Of course, we do not have this operator in this computer architecture. So what we have to do is to subtract until we are left only with something that is smaller than Y. So 13 minus 3.
It's 10.
I have a problem with this. Just 1 second. Just 1 second. I don't know why it's not working anymore. With the mouse it's working, with the pen it's not. Okay. Okay, so we have to continue doing this, subtracting from what's remaining from x until we get something, we get a result that is smaller than b or than y. So 10 minus 3 is 7. 7 minus 3 is 4. Then 4 minus 3 is 1. Once we have something that is smaller than 3, we have the remainder of 16 divided by 3. Okay, so let's write a program that does this using the control structures that we have and the operations that we have. So we have begin, then the name of the program, let's call it remainder, then 2 points, colon, and then we can start our program. So as we said, so do you want to try to tell me what should we do now?
First of all, we need to check if A is already smaller than B or X is already smaller than Y.
Yes, but Yani, before that, because we do not have anything in A and B yet, the
Load
data now,
A.
the data now is in memory, so we have to load. So let's look at the syntax. Load address of X into A. So here we have to load the address of variable X. Oh, I have a problem with this. Address of X into A, and then
Load address of Y to B.
Load variable Y into register B, and then
We do the if A is less than B.
Yes, we need to, before starting this subtraction here, we need to check first, maybe A is already smaller than B, so, or X is already smaller than Y. So here, if, how should we write the?
If A is less than B.
The if, okay, if F smaller than B, what should we do?
End the program. End remainder.
But what is the result?
We have to save first.
What is the result if A is smaller than B already?
Save A.
Save
A is the remainder.
So where should we save A?
At the result. The result.
Save A into Z.
Okay, so into the result should be Z. So save A into the memory location Z, and then
we have to stop the program.
We just need to stop the program. Stop remainder.
And F.
And if, and then?
If A is bigger than B.
If?
Shouldn't
A is bigger than B.
Shouldn't we repeat?
Here, the if we do not need it because the repeat will do it.
Until A is bigger, until A is smaller than B.
Now, so we will repeat doing this thing here. So we'll repeat doing this. So repeat until what?
A is smaller than B.
Until A is smaller than B. What should we do?
A minus B. Sub A, B.
Sub A, B. This will do like A minus B. And we'll put here, this will be like the register A. This will be B. and this will always be register RS. RS, is it RS here?
Yes.
It's register RS. Yani always the result will be saved there automatically by
Then we
itself.
save RS into Z.
So here we have to save RS where?
Address Z.
Why should we save it into Z?
I think at A. So
هنا A minus B gives RS. Now we just need to put RS again here into A,
back into
so that we can use it again. It's the way it's a waste of time to save it into memory and then reload it again. Okay?
Okay.
Because the old value of A, we do not need it anymore. So we can write on top of it. So we can save RS directly into A, and then we can do sub A minus AB again. So here what happens after we do this? What should we do now?
we end the repeat.
We end the repeat. End the repeat. Is it like this? Okay, and then?
Well, then we save A at the result, which is Z.
And here the system, the loop will loop until it will do this. It will loop until we arrive at the point here. It will stop here because we have A is smaller than B. Okay, here it will save 1 into A again, and it will not continue doing -3. It will, when you make save RSA, it will put 1 into A, and then when you do the test again, 1 will be smaller than 3, A will be smaller than B. So now what we have to do is
We have to save A at the result.
Save A to the address of the variable Z, and that's it. And the program has terminated here. And reminder. Okay, I think we should stop here. Maybe I think this is enough.
Yes.
If you have very quick questions, I can answer, and otherwise I think we can stop here.
In chapter 4, other than this subject, everything else will be theoretical, multiple choice.
Yes.
Thank you, Doctor.
Thank you.
يعطيك العافية دكتور.
Thank you, Doctor.
Thank you, Doctor.
السلام عليكم.